This is section 1.6, using linear equations to solve application problems. To get to the chase, these are going to be your first stab at word problems. And on these you can read, so I'm not going to necessarily read them. You can pause it if you would like. But first off, we've got a rope. We know our rope is 76 feet long, so let's draw a picture. We've got a rope that's 76 feet long. We know we're cutting it in two pieces, so we're going to make a cut somewhere. One of the pieces is 4 less than 3 times longer than the other. So we don't know how long this first piece is, so let's just call this part x. We know the second one is 4 less than, which means it's something minus 4. And it's 4 less than 3 times longer than the other. So 3 times the length of the other. So we know our first cut is x, and our second cut is this 3x minus 4. We know both of these lengths together has to be our total of 76 feet. So our equation is just x plus the 3x minus 4 equals 76. Here's our first piece, here's our second piece. And now we can just solve these like we did yesterday. So x plus 3x is 4x minus 4 equals 76. Add your 4. We'll get 4x equals 80. Divide by 4. X equals 20. And now let's go through. We want to know how long should each piece of rope be. So we know this piece should be 20 feet. And when we plug 20 in for x here, we'll get 3 times 20 minus 4, or 60 minus 4, 56. So 20 feet and 56 feet. There we go. See, that one's not too bad. Next up, now we're buying a phone. The phone is on sale. We know how much it is right now. We know how much it was previously. We want to know how much was it marked down as a percent. So we know what we're going to pay is this $250. That's what we're paying. And this is what it cost before. So our original cost, this is what we're paying. But we took off some percent of the original. So some percent of that original. And we took it off because it's on sale. So now when we solve this, we'll distribute that negative p, or multiply that negative p, times that 400, and it's just negative 400p. The p is already on the right side, so let's move this 400 by subtracting it. And 250 minus 400 is negative 150 equals negative 400p. We still have to get the p by itself, so divide both sides by negative 400. We can divide a 10 out from both of them. And then we have negative 15 over 40. If you do your long division, we'll get 0.375 equals p. Remember, we want it as a percent. So for percents, you want to move that decimal place 2 spots. That 37.5% was how much the phone was marked down. That's how much on sale it is. Now we're going to build a rectangular dog run. So we've got a puppy, it needs some place to run. So we're going to build a rectangular dog run. We know we've got 32 feet of fencing. So that means all the sides together can only equal 32. And we know one side of the pen is 4 feet longer than the other. So we don't know what this side is, but we know that the other side's 4 feet longer. We also know it's a rectangle, so that one will be x and this one will be x plus 4. We also know we have 32 feet of this fencing. And And this fencing is what's going around the outside. So we've got our x plus 4 plus x plus our x plus 4, adding all 4 sides. And that's our 32 feet that we have got total, because that's our perimeter. So let's clean up this left side. When we combine all of our x's, we've got 4x. When we combine our 4's, plus 8, subtract our 8, 4x equals 24. Divide both sides by 4, and x equals 6. But we want the dimensions of the whole pen. So that means this is 6 and this is 10. So the dimensions are 6 feet by 10 feet. So now we want to buy some cookies. The dozen is $13.50. However, we can buy extra cookies for only 75 cents. So if we have so much money in our pocket, how many of these extra ones can we get? So we know we were getting a dozen, which is $13.50. And we want some more cookies, which are 75 cents. We don't know how many of them we can get. We don't know how many, so it's times our x. But we know total we can spend $17.25. So now let's just solve this equation. So subtract the $13.50 from both sides. And we're left with 0.75x equals 3.75. Divide by 7.75. Or think how many times does 75 cents go into $3.75? 5 times. So this means we can buy 5 extra cookies with the money that we have. Alright, so we're on Craigslist. Somebody's selling baseball cards. We have got Cubs cards and White Sox cards and Cardinals cards. So let's start. We've got some Cubs cards, we don't know how many. We've got some White Sox, and then we've got some Cardinals. Alright, so we know he has 1/3 as many Cubs cards as White Sox. So that means we're comparing the Cubs, the amount of Cubs cards he's got, to how many White cards. And we also know he's got 3 less than twice as many Cardinals cards as White Sox. So notice we're comparing both of these to White Sox. So let's go ahead and do the White Sox as our variable, because both of them are getting compared. Now let's go back to the Cubs. He's got 1/3 as many of them. So that means he's got 1/3 as many cards as of the White Sox. And now for Cardinals, he has got 3 less than, so that's something minus 3, twice as many. So that's 2W. So now notice we have all 3 of these using the same variable W. Now, we also know that he has 37 cards total. That means the number of his Cubs cards plus the number of his White Sox cards plus the number of his Cardinal cards is 37 total. So now let's substitute in our expressions that we already found. So for Cubs, we know he's got 1/3 W. He's got W many White Sox and 2W minus 3 Cardinals. And now we'll just solve this. So when we combine our W's, 2W plus 1W is 3W, and then 3W plus 1/3 is just 3 1/3 W. going to change this to an improper fraction. And remember to do that, you keep your denominator the same, and then it's 3 times 3, which is 9, add 1 is 10. And if you look, 10 over 3 is 3 1/3, so we did the right thing. And now we can divide by this 10/3. But remember, dividing by a fraction is the same as multiplying by its reciprocal. And notice we can divide 40 and 10 both by 10. So W equals 12, because it's 4 times 3. So now our question was asking, how many cards does he have for each team? This means, since our W was 12, he's got 12 White Sox cards. He's got 1/3 as many of these for Cubs, so 1/3 times 12 is 4. And then we've got 2W minus 3, so 2 times 12 minus 3, or 24 minus 3, 21 cardinal cards. And we can double check this by adding them up and seeing if we get the 37 we need. So 12 plus 4 plus 21, 12 plus 4 is 16, plus 21 is 37, which is what we wanted. So we are correct. And now a fulcrum problem. We have a woman that's using a bar to lift a stone. So we've got a stone, we've got a woman, and we're using some sort of bar. We know the bar is 10 feet. We know the stone is 210 pounds. And we're using a fulcrum right here at 3 feet away from the stone. We're using this to lift. And so our key formula here that we're going to be using is our force of one of them times that distance to the fulcrum. That's got to equal out the force of the second one times the distance of that second one. Because to lift it, we've got to have those equal. So let's substitute in. If we look first over here, we are asking how much force she's got to use. So we don't know how much this force is going to be. So that's our variable. We do know if the whole thing is 10 and this is 3, then this part's got to be 7. So the distance from her to this fulcrum is 7. And now our force 2, we know that's a 210 pounds because that's how much the stone weighs. That's the force the stone is putting on the rod. That distance then is 3 because it's 3 feet from the stone. And now we'll just solve this problem. So you've got 7x equals 630. Divide by 7. And x equals 90 pounds. Not too bad.